All right, so here's our next question on the parabola function. It says in the sketch, A is an x-intercept and B is the turning point of the parabola. We have the equation in standard form, but we don't have any values. The straight line AB is defined as g at x equals to 3x plus 6. We have D as that point, and then is a point on F, and C D is perpendicular to the x-axis. B is the y-intercept of F and G. All right, so that's what we are given. So now let's see. The first question says, determine the coordinates of B. B is the y-intercept of both of these graphs. You find it on the parabola, but you also find it on the straight line. So 11.1, you're going to say that the coordinates of B are the y-intercept there from the straight line is 6. We're going to say 0 is to 6. Okay. Now, next question says we should determine the coordinates of A. Now, A, we find it again on the straight line, but also we find it on what? On the parabola function. So we are going to use the straight line because we don't have the equation of the parabola. So we're going to find the x-intercept, so 11.2. You're going to take your g of x, make it to be 0, and then you have 3x plus 2 plus 6. Take the 6 over, that's negative 6 is equal to 3x. Then you divide by 3 on both sides, you're going to have negative 2 is equal to x. So now you can conclude that the coordinates of A are negative 2 is to 0. All right, next question says, determine the equation of the parabola in the form of y is equal to. So we are going to find the equation of the parabola using the turning point format, because if we check here, B is the turning point of the parabola. So we have the turning point there. So 11.3, we're going to say that y is equal to A x minus p squared plus q. Now, if we check, our x value is 0, right? So which means that our p is what? Is 0. So we just want to have y is equal to a x squared. Our q is what? Is 6. So we're going to say plus 6 over here. Now we just need to find the value of what? A. So we need a point that we can substitute. And remember, we've got the coordinates of A here as negative 2 is to 0. So we can substitute those. So in place of y, we're going to put 0 and then have A here, negative 2. You square that and then 6. Take the 6 over, that's going to be negative 6 is equal to negative 2 squared, that's going to be 4. So we have 4a here. So you divide by 4 on both sides. So you're going to end up with your a as negative 3 over 2. So it's the value of a. Now we can conclude that our equation is y is equal to, we got our a as what? As negative 3 over 2. So negative 3 over 2 x squared plus 6. That's our equation. Right, done. Let's look at the next question. It says, calculate the length of what? The length of CF. So now, to calculate the length of CF, you would need to have what? The coordinates of F, right? So we need to figure out what those coordinates are. Remember, you were given the coordinates of D. They said that the coordinates of D are negative 1 over 3 is to 35 over 6. So now, this line is perpendicular to the x-axis, which means every value or every point here will have the same x value. So F, the x value will also be negative 1 over 3, but we don't know what is the y value. And then C, the y value will be negative 1 over 3, the x value rather, and then the x value, the y value will be 0. So what we need to find is the y value of F. So which equation are we going to use? When I use the equation of G, because F is on the straight line. So 11.4, we're going to say that you are looking for G at negative 1 over 3. So we're going to have 3 multiplied by negative 1 over 3 and then plus 6. So this is going to give us our answer as 5. Now that we have our y value for f, we have the y value for f as 5. This is a vertical line. To find the distance, you can just say the big y value minus the small y value. So CF will be 5 minus 0, which is what? 5 units. All right, so it's just 5 units. Done. Let's look at the next one. It says a new parabola is obtained when the y-axis is moved 2 units to the left. Okay, write down the coordinates of the turning point of the new parabola. So you're shifting 2 units to the left. Now, you're going to take the turning point. The turning point was what? Was 0 is to 6. Take the 0, shift it 2 units to the left, which means we would have shifted it to negative 2. So then it means that the turning point here, 11.5, we're going to have negative 2 is to 6. So those are the coordinates of the new turning point. So you're taking 0, subtracting it by 2 because we're shifting to the left, which gives us what? Negative 2. All right, so let's see. We have another one here. It says a new graph P is obtained when F is translated 6 units downwards. So we are translating it 6 units downwards. So we're going to take our original equation. Now, what is our original equation? I want to do it here. We were having y, the graph of f, right? It was y is equal to negative 3 over 2 x squared plus 6. So you are translating this one 6 units downwards, which means you're going to say minus 6 here. So therefore, it means that the equation of p at x is going to be negative 3 over 2 x squared, and then the 6 is gone because you said 6 minus 6, which is 0, right? So that is the end of this question here. The next question we are now dealing with, the next question we are now dealing with inverses. We're going to tackle these in a specific, in another tutorial where we are focusing only on inverses.